Okay, here we go. Final exam review, part 3, quadratic functions. All quadratic functions take the form of ax squared plus bx plus c. It must have an x squared term for an equation to be quadratic. Okay, it has to have the x squared term. Without that, it's not quadratic. Okay, so quadratics make parabolas. So they have a y-intercept here, and then they have x-intercepts. Usually they have two, sometimes they have one, sometimes they have none. Sometimes they open upwards, like this is a U shape, this is a positive A value, and sometimes they open downward, or more like a mountain shape, or a hill shape. So if A is positive, it's going to open up. If A is negative, it'll open down. Okay, A can't be zero. It has to either be positive or negative. Okay, so if A is positive and it faces up, then it'll have a minimum. If A is negative and it shapes down, it will have a maximum. So like gravity problems where a ball goes in the air and it has like some max value that it reaches and it comes back down again. Okay, Mr. Reed wants to host a fundraiser for the class of 2022 at the skating rink. The profit the class will receive from selling tickets is P of x equals negative 15x squared plus 340x, where x is the price of the ticket. Okay, evaluate the following and write a some statement describing the answer, means, and context to the situation. Okay. All right, so our function is negative 15x squared plus 340x. Okay, so in place of x, I'm going to put 10. Let me just confirm I have the right function. Negative 15x squared plus 340x. Cool. All right, so negative 15 times, let me just type this in the calculator real quick. So negative 15 times 10 squared plus 340 times 10 is 1900. Okay, so what does that mean? That means that if the tickets are $10, then they'll make a profit of 1900. Let me make sure that's right. Okay, received from selling tickets, where X is the price of a ticket. So $10 ticket will give them 1900 in profit. Okay, $10 ticket leads to 1900 in profit. All right, so the P of 6. Okay, so negative 15 times 6 squared plus 340 times 6. All right, negative 15 times 6 squared plus 340 times 6, 1500. Okay, so if it was a $6 ticket, that would lead to 1500 in profit. Okay, so let's say parabola A has the equation f of x equals x squared plus minus 6x plus 16. Parabola 2 has 2x squared minus 12x plus 18. Determine the following. Okay, so what direction do they face? Okay, so part A, what direction do they face? Well, this is positive, this value here. So this is, for the first one, A equals 1, and for the second one, A equals 2. Okay, so they're both greater than 0, so this will face up. Okay, those are up. Okay, which one will have a higher minimum? Okay, well, we gotta go into the calculator to find the minimums for those. Okay, and what are the x-intercepts of parabola A? So the x-intercepts of parabola A. So we're gonna find the minimums of these two functions, and I'll do that with the calculator. Okay, so we have x squared minus 6x plus 16. Okay, that will be our y1 or our first f of x. Here we have 2x squared minus 12x plus 18. All right, and then we go second table. Okay. All right, and what we're looking for is the minimums. So the place where the functions fold. So if we look here, we're looking for where the patterns repeat, and luckily it just happens to be right on my graph right now, where we have the pattern repeating, and the same thing here. The patterns repeat. Okay, so this value, these values here are the vertexes. That's the minimum of each function. Just happens to be at the same place. Okay, so the minimums are at the same place. So we have 3, 7 for the first function, and then for the second function we have 3, 0. Okay, so those are our two minimums. And so I think the question was, which one has a higher minimum? And the higher minimum will be this one. Okay, that's the higher minimum. So that will be the first function, y1 or f sub 1. The first function will have the higher minimum. Okay. So which graph has a higher minimum? It would be the first one. So I'll just put the first one. And it was 3, 7, and the second was 3, 0. Okay, so this is higher. Okay, and what are the x-intercepts for parabola A, which was y1? I'm sorry, what are the x-intercepts of parabola A and parabola B? Okay, so parabola A and parabola B. Okay, well, it looks like parabola A doesn't have any x-intercepts. Okay, its lowest point is 7, so it's not going to have any. And the second one looks like it only has one x-intercept. So let's just look at Zoom 6 real quick. And so the first one has no x-intercepts. The second one has a single x-intercept at 3, 0. Okay, so the x-intercept there would just be 3, 0. Okay, so for A, no x-intercepts. We call those zeros, no zeros, or no solutions. And for parabola B, just had one at 3, 0. Okay. Up next, example 3. You want to host a dinner party to celebrate the end of your first high school semester with your friends. The cost of hosting the dinner party can be determined by the function c of x equals 10x plus 1200, where x is the number of friends attending. To cover the cost of the dinner party, you decide to sell tickets to your friends. You determine that the income you will make from ticket sales is I of x equals negative 20x squared plus 350x. How many friends must come for you to break even? All right, well, breaking even is when these two functions are going to be equal to each other. Okay, you break even when cost and income are the same. So we got to figure out when these two functions are going to be equal to each other. Okay. All right, so our first function is 10 of x, oh, not 10 of x, 10x plus 1200. And our second function is negative 20. Make sure you use that negative sign in the front. Negative 20x squared plus 350x. Okay, and all we're going to do is go to our table and find out when these things are going to be even. Okay, when do they cross each other? Okay, looks like, 1250. 1250 is one place where they're the same. And let's see if there's another place where they're the same. Oh, 1250 and 1320. Okay, so we have two locations here where they're going to be the same. Okay, so here at $5 and here at $12. So 5 and 12 are going to be the two places where these two functions are going to be the same. Okay, so those are the break-even points, 5 and 12, because we have the same cost and the same income. So it'd be basically you threw the party for free. You didn't make any money, but you didn't lose any money either. Okay, or the dinner. Okay, so the answers here, either 5 or 12. All right, up next, we have 3x plus 2, and then x minus 6. Okay, so using our punnet here, 3x and 2, x and minus 6. Okay, so we end up with here in this box 3x squared, 2x minus 18x, and then negative 12. And then we'll add these two values together. We end up with 3x squared, negative 18 plus 2 is negative 16, and then minus 12. Okay, another way of doing it is distributing here. We can do it this way. Okay, so 3x times x, the first curve here is 3x squared. 3x times 6 is negative 18x. 2 times x is 2x. 2 times negative 6 is negative 12. 3x squared minus 16x minus 12. You get the same answer either way. Okay, here we got 5x minus 1 times the sum of x plus 7. All right, so 5x minus 1, x 7. So 5x squared minus x, 35x minus 7. Again, add the two middle terms together. We get 5x squared plus 34x minus 7. Same thing, we can distribute the 5 here, and then we can distribute the negative 1 here. So 5x times x is x squared plus 35x minus 1x minus 7. Okay, and then we get 5x squared plus 34x minus 7. Combining the two middle terms, 35 minus 1. Example 5. Okay, so which of the following is the greatest common factor of the expression 8x squared plus 16x? Okay, what's the most I can pull out of these two? I can divide them both by 2. I can divide them both by 2, but I also can divide them both by x. I can get a 2 and an x out of both of them. Okay, so I can divide this by 2 and x. I can divide this by 2 and x. Well, also I can divide it by 4. 4 goes into 8 and 16. Well, also I can divide them both by 8. Okay, so let's see if we can break them down as much as possible. See what we have in common. We can divide them both by 2, 4, and 8. We can divide everything by 8, and we can divide everything by x. So is there an 8x somewhere? Right here. Okay. So this 8 is the biggest thing that goes into both of them. Okay. So we had 2, 4, 2 works, 4 works, x works, but 8 works as well. And that's the biggest one that will divide into both of those numbers. Okay? You can divide 8x squared by 8x. You can divide 16x by 8x. Okay? And that was our last example.